Hey everybody, let's talk about a tool called a wedge. So it's just like here, a wedge at B. It allows you to apply a load, for example, toward the left here, and then cause a motion in a different direction, say vertically here. Okay, and in this application, there's friction all over the place. So it's good practice solving problems with friction. So how do you do it? Always start with free body diagram. So here's block A, and then here's block B. Okay, now let's draw all the forces acting on the blocks. So I'll start with block B. It has weight, which is given 25 pounds. And maybe now's a good time. What's the weight of a 25-pound block? 25 pounds. What's the weight of a 10 kilogram block? That would be 10 kilograms times 9.81 meters per second squared. Right, so 98 newtons. So just be mindful about kilograms, newtons, and pounds. Right, pounds. A pound is already a force. Okay, so that's 25 pounds. And then what else? We got this force here, over here. Okay, now the wedge block B is in contact with the ground. So there's a normal force from the ground. And then there's also block A over here. So there's a normal force from block A, like that. And then let me just label them N1 and N2 for lack of creativity. Okay, now if the block slides toward the left, which way is the friction from the ground? Opposing the motion like this, right? And that will be, it's moving, so it's kinetic friction, and I'll just call it 1. And imagine block B is sliding this way. So what's the friction from block A? It's going to be opposing the motion this way. Okay. And let's see, that looks like we got everything. Okay, let's go to block A. So right here, normal force here, equal and opposite, Newton's third law. And then here, this friction here would be equal and opposite here, Newton's third law. Okay, let's draw all the, block A also has weight. And then it's in contact with the wall, so there's a normal force from the wall. And then block A would be moving upwards, right? So then the friction from the wall would be opposing that motion this way. Okay, so now we got both free body diagrams. And then you can just pick coordinates however you want. And then write out Newton's second law decomposed. Okay, so in the x direction, I'll start with this one. In the x direction, we got N3. The x component of N2, which would be negative N2 sine 10 degrees. The x component of that, negative FK2 cosine 10 degrees, equals mass A times its acceleration, which it's not moving in the x direction, so that's 0. Okay, y direction, we got this, negative FK3, the weight, the y component of this, which is negative sine, and the x component of this, which would be, the y component of this, which would be positive cosine, equals mass times the y component of acceleration, which it is moving in the y direction, but at a constant rate. Constant rate means the acceleration is 0. Okay, and then you do the same for this free body diagram. And then note that, if you look right here, this FK3 is proportional to normal force 3. And then see FK2 over here is proportional to normal force 2. and we were given the coefficient of friction over here. So you just substitute that here, substitute that here and here, and then basically you just have two unknowns, n2 and n3, for these two equations. You can solve those two, and then you write equations for this, and then you would have unknowns n1, n2, and f. So then 4 equations, 4 unknowns. You would already have solved n2 here, which means you'll know n2 over here, and then you just have n1 and f to solve. Okay, so this is best by example. So let me just get to just a different example, and I'll move a little quicker. So block A, you just draw the free body diagram. Block B, draw the free body diagram. Each of them has weight. For block A, there's a force here. And then if it's going to move impending downwards, then there's going to be friction opposing the motion this way and this way, right? Friction. And then there's normal force from the wall, normal force from block B. I'll just label these. And then this is static friction. Static friction. And then for block B, here's the normal force from block A. And then Newton's third law. These are equal and opposite. And then it's in contact with the ground, so there's a normal force. And then if it's going to go toward the right, then the friction will oppose the motion toward the left. And there we go. We got the two free body diagrams. For each one, you write Newton's laws decomposed, and then for this one also. Right, and then you have as many as 4 equations for however many unknowns. Okay, let's try another here. So now we have 3 blocks. So you have 3 free body diagrams. Okay, and then let's see, right, we have this force here, this way. So then if that block slides toward the left, then there's going to be friction opposing the motion here, and then it's in contact with the ground, so there's a normal force. And then the block itself has weight. And then there's a normal force from block B, like this. And then if block C moves left, what happens to block B? It's going to go up, right? So the friction opposing that motion on block C is like this. Okay, so I'll just label these. And this is going to be static. Okay, now over to block B. Block B has weight. And look at this, equal and opposite. Right, Newton's third law. And then if block B moves up, let's see. I drew these backwards, sorry. If block C moves toward the left, then there's going to be friction from block B going this way. And then if block B moves up, then there's friction this way opposing the motion on both of these. And then there's a normal force here. And did we get everything? I think so. Okay. Then block A, there's a normal force from block B. And then block A is not going anywhere, but block B is sliding upwards. So then there's going to be a friction force like this. And then block A has weight. And it's in contact with the ground. But it's not moving, so there's no friction here or here. So that's it for block A. All right. Oh, I forgot that it's in contact with the ground, but it's also, I forgot the wall over here. There's the wall. Okay. Let's try one more. Okay, so let's say here we have block A, block B. Okay, so block B, there's a force here. And let's see, we're trying to see what's going to happen. So there's going to be a normal force here and here on block B. And then if it moves toward the left, then there's going to be friction opposing the motion like that. Let me just label these. Okay, and then this, and then block B has weight. And then block A has weight. And then right here, Newton's third law, equal and opposite. There's a normal force from block B. There's friction because block B is sliding potentially toward the left. And what else? There's, oh, it's in contact with the wall here. Okay, and then that's pretty much it for this one. Okay, so these problems with wedges are arguably simple but tedious. So it's just a matter of just being careful drawing the free body diagrams. Once you have the free body diagrams, then you just write out Newton's second law, decompose for each free body diagram, and then really like figure out which are your unknowns here. So these are the unknowns. And then you do the same here. So highlighting the unknowns allows you to figure out where you want to solve first. Okay, so just keep practicing these wedges. Let me know if you have questions. I'll see you on the next video.